Hello guys, welcome to the third lesson. Today we will modelize a sample steel structure 3D, modelization 3D. So let's start. So here is the first window in front of us. Today we will choose 3D model. So as we see in the last lesson, here the interface of a program. Here we have a grid and here toolbar. So the first step in our project, we have to define reference here. So we have to define here error code, for example, and we have to okay, it's okay. And then we have tools and job preference. Here we have to verify the code, which code we work. So here, and we have here units dimension. So we have to define in millimeter or our dimension. So here all we have to force, we have to define on decanewton. So decanewton here, moment and decanewton too. So decanewton millimeter. Okay, stress meganewton. Okay, length unit 2 on millimeter, all on millimeter, force unit in decanewton. Okay, other displacement on millimeter. So what we have to weight, mass. Okay, so material error code, we have here steel, this type of steel. Database, we have to verify database. So we have here error code is good. So load, the same thing. So normally it's good. So okay, so second step, we have to define the grid of a project. So we have to follow this step here. So grid. So my project is simple project. We have in X, we have a column every 6 meters. So Cartesian here, okay, it's good. Then here we have numbering 1 2 3. So 0 and then 6 and then 12. 6, 12 and then 18. So that for X, for Y in this sense. So for Y we have it's 1 2 3, it's ABC. We have 0 and then we have I make a mistake, it's in millimeter, so 4000. I have to modify here. So here it's 6 millimeter, and I have to delete here, and here I have like that, and I have to delete this here. I have to delete this. So like that is good. For Z I have two level, 0 on 1 2 3. I prefer value like that, it's good. And then I have the second 3 meters, for example, and the second for 2000. Apply. Okay, 2000. Here it's not 2000, it's 5000. Apply. as we can see, we have this grid. Okay, so here I have what? I have X with Z. I can change the grid from here. So I have XZ here, I have Y with Z, so I have AB with the level, and then I have here I have X with Y. So if I X with Z like that, close, I can to determine here which level I am. So here I am in 0, here and I have 4000 for I can now I can draw in the level of 4000. So and here I can, from here I have a few in 3D like that. So I prefer to draw in 2D. So this step is okay. Second step, here node no, member no, material object not object. So here material, which column and beam I'm going to use. So I have EBE 100. Okay, for example I will choose HEA. So HEA here. So 100 I will choose for it, let's say 100, just 100. And so I see here it is added here, and I can choose, for example I will change ABE for ABE 140. Okay, close. So I can delete here, delete this profile, yes. So I'm good, I can start drawing. So I will draw column on EBE 140. So I am in level 0. So here I am in level 0, so I can start like that. Okay, I can do copy for this column here. So I go to edit, so edit, and then move or copy. So I select, I have to select the element. So here move copy, okay, and then I will select. So I have copy, I have move, so and I have number of repetition. So I select this factor, for example. It's not good because I have to select from here to here. So I do undo, then I have to reselect, edit, copy. So it's copy from here to here, close. So it's okay. So then the next step to draw beam. So I choose, for example, HEA. So I click here, and then I can do, for example, copy. So edit. So I select that, so it's good. Then from here to here. So I have now the first level, the first story. So I will draw now the column here, from here to here, from here to here. So the same things. I'm good, and then I draw for the beam from here to here, and from here to here, and from here to here. So my first phase is done. I can see that in 3D. It's like that. I can see the form of my structure. So then we can do copy in the plan of X, Y. So I choose here I am in 3D, so I choose here X, Y. So then I choose which level. For example, here in 0 I see nothing. Here in the level of 3000 I see my structure. So I select all the structure and then I do copy. So copy from here to here. It's good. So I verify my work in 3D. It's not perfect, so I do that manually. So select. I select the column. I use shift or so like that, and then edit, copy. So from here to here. So it's not bad. So I need 2 pins here. Like that. So my structure is done, and then we speak it the last lesson for this option. So I can click here, for example, and I go to member. So I can, for example, do member number, name, sample, apply. So yeah, there is sample for my member. So color, like that. I can define my structure more easy. So it's this filter by section. So I have section RBE in yellow, and this yellow, and then that in blue. So je ne sais pas, c'est okay. And then I determine the support. So support here, I don't okay. Pin it. So pin it, I can click in my support like that. Okay, it's good. In the last, I need the bracing for my structure because I don't put a fixed support. So for the bracing, I need to define a new profile, CAE, for example. CAE, okay, not bad. I can define this section. So I need bracing here, from here, and bracing here, from here. Same things. So okay, I can put a section here, for example. From here to here. So I'm good. It's done. and then I will define the load types. So I have dead load and I have live load, and I won't define a wind load because we have a long work to define the load work. Here in Euro code they specify many cases. If we have industrial industry building, so we have to, so according to the Euro code we have many parameters here. We have dynamic operation, for example. We have reference wind, we have to define it. So we have pressions C, we have coefficient C, we have moyenne wind too. So we have parameter according to the earth, to the site, parameter according to the site. So type of site and the same thing. So we have many parameters to define and apply the wind manually in the structure. So for the moment it's not the goal of this video, so I will delete this parameter. Maybe I can make a video just for how to calculate wind forces in many type of structure. So I need now to do calculation for the program for determining the self weight of my structure. So then I have to determine the forces. So I have to define which load I have here. So then forces. So maybe I put nodal forces. So for example in decanewton. So I will put, for example, then for example 40 decanewton, and then I have to define node. So I define here, I press shift, so I define here, for example, and here, and then apply. Yes, so as we see I apply these forces here. Maybe I define uniform load here, so I define, for example, I define 60 and then I have to apply load here, here, and here, and here. Then apply. Okay, it's good. I have many type of loads here. So for surface I have a load, but I need to determine a surface in my structure. I don't forget to put save, so I have to save my project 3D. Save. So for applying my loads, surface load, I need to determine a cladding. So geometry and then cladding. So I have many ways to define my cladding. So I have rectangle, I have or circle. I can define it by 3 points from here to here, for example, to here, and then I have my cladding. So apply, no, so I so it's good. Then I can surface here for example I can put it's take a Newton millimeter, so I can put 0.01 add, and then I can define here for example apply, so it's good. For going to the load table, so I need to click right click here and then table, so here load, okay, loaded, so 1 date load and 3 life load, so we are good. I can close my table, so table load, okay, it's closed, so good. And the next step, what it is the next step is to define the code, steel code. For beam we have flexion, we don't have compression, we don't have torsion or tension. For column the same things, we have just compression. So we have two simple cases for beam and column. Column we don't have for loaded here, so there is just buckling in the column, and there is lateral buckling for the beam. So for buckling here I have to define the different type of parameters I have for buckling and lateral buckling. So as we can see here, column, it's we don't have a complicated structure, so we don't have for example we don't have a beam here divide the column on two part, so coefficient of buckling is one. It's one. We don't have here for example for the beam we don't have a column here or a support here for dividing the lateral buckling by two. So it's simple. For the column for example, when we click here we have buckling in Y, so buckling in Y, so in this sense like that and like that. Buckling in Z is in this sense like that and that. So here we don't have support, here we don't have, not in this direction, and in this direction we can let the coefficient 1 and coefficient 1 here. For lateral buckling the same, here we can define the type of support. So here we have pennant 1, here we have 0.5, it's for fixed in fixed element in the two ends. So for us it's 1, it's okay. So column it's okay, 1 it's okay, not problem. Lateral buckling we don't have lateral buckling, it's column and then close. For beam the same way, so buckling in Y, so Y it's in this direction, buckling for Y is in this way and this way, and buckling for Z in this way. We don't have support, we don't have secondary beams, so we can take the all lengths here and the all lengths here, all back, all the types, so we have one here. For lateral buckling the same way too. So lateral buckling we don't have support, we don't have support in the wings of our beams. So normally if we have support here in the upper wings, so we can define that here. So we have upper flange and lower flange, and the beam is clear in all the lengths, all the longer. So here we don't have support here in the upper and in the lower, so it's clear it's like that. So save. Okay, it's close. So now we have to define column and the parameter of column and p. So here we click, we have to click here and then here, right click and select similar. Select similar by cross section. No, it's a cross section. So select similar cross section. Here it's good, apply. So all these elements they have the same parameter. Okay, for the beam the same way. So here we can go design code parameter and then here click here and then like that we click here and then beam on apply. So it's good. Bracing we have to define the code parameter for bracing. So we can select all bracing, cross section, and then from here release and pin it. The same way I can go to design and then code parameter and then define a new parameter for the release or code parameter for this bracing. So I can buckling length coefficient, so I put x here and x here. So and here I note bracing for example. So this is a new parameter for bracing. So it's good. Now I think we are good. We define the structure and the bracing and the loads. We have to define what? We have to define combination. So automatic combination. So here manual combination. I have to verify here. So 1.35. I prefer manual. So manual combination. No. Automatic combination. Simplified. Here. Simplified automatic combination, and then more we have to define. So I don't need here, I don't need here. Ultimate limit state, it's okay, and service limit state, it's okay too. So quasi permanent, I don't need. Characteristic, okay, it's good. Two-way, two cases. So ultimate and service generate. So if I click here, I can find all parameters I need. So day load, life load, ultimate, service, it's okay. And now I finish here, so I go to calculation. Normally here design, load result, diagram. Here I can see for example deformation here, normalize. So I have it's